Good morning, viewers. Your teacher today is Dr. Bbosa Science. Dr. Bbosa is a teacher at the Science Foundation College, the best school that teaches sciences, and a team leader of digital teachers. Today, 16th June 2019, we are going to consider electrolysis. Electrolysis is the decomposition of ionic compounds in molten or solution form into constituent elements by an electric current. An electrolyte is an ionic compound that conducts electricity in molten or solution form. Mechanism of electrolysis. Consider electrolysis of molten sodium chloride. Molten sodium chloride will dissociate into sodium ions plus chloride ions. When we get a container which contains sodium ions and the chloride ions, then you add a conductor from a cell. By conversion, the long stroke means a positive charge of a cell, then the short stroke means a negative charge of a cell. So you put another conductor into solution. The conductor from the negative pole of a cell is called a cathode. A cathode is a negative conductor. Then a conductor from the positive terminal of a cell is called an anode. Anode is a positive conductor. Unlike charges will attract, the positive ions will migrate to the cathode, the negative ions will migrate to the anode. What happens at the cathode? The cathode is an electron rich. It has very many electrons, so the sodium plus will gain an electron to form sodium. What happens at the anode? Anode is electron deficient. We'll pick an electron from chlorine. So chlorine minus an electron, you get chlorine atom, but chlorine atom cannot exist on its own. So chlorine atom plus another chlorine atom will get chlorine molecules. In essence, sodium chloride has been decomposed into sodium, one of the elements which make sodium chloride, and chlorine, one of the elements which forms sodium chloride. So electrolysis has taken place. We said that electrolysis is the decomposition of an ionic compound into constituent elements by passage of an electric current. Then the apparatus where electrolysis is carried out is called electrolytic cell. So this is an electrolytic cell. The apparatus where electrolysis is carried out is called an electrolytic cell. Selective discharge of ions. Selective discharge of ions in electrolysis. We consider electrolysis of sodium chloride solution. In the sodium chloride solution, sodium will ionize to form sodium plus aqueous plus chloride minus aqueous. But there is water molecules. The water molecules will ionize to form hydrogen plus aqueous plus OH ions aqueous. The positive ions will migrate to the cathode. The negative ions will migrate to the anode. The question is, which of the two ions receives the first electron? Which of the two ions loses the first electron at the anode? We saw that at the cathode, cations receive electrons. At the anode, anions lose electrons. So the question is, which of the two ions receives the first electron? Which of the two anions lose the first electron? Factors that influence which ion is liberated first. The first factor is position in the reactivity series. The order of reactivity of ions for cations, we start with potassium is higher than calcium, than sodium, than magnesium, than aluminium. Then we place carbon there, then zinc, then iron, then lead, then copper, then silver. Hydrogen is placed between zinc and iron, or lead and copper. Some of these reactions sometimes behave as if hydrogen is higher or is lower. Then for ions, sulfates, nitrates, chloride, bromide, iodide, and OH. For this factor, the ion lower in electrochemical series is discharged first. In this case, at the cathode, hydrogen is lower than sodium in the reactivity series, so it will be discharged first. So 2 hydrogen aqueous plus 2 electrons will give us hydrogen gas. Similarly, OH is lower than chlorine in electrochemical series, so at the anode, OH will lose electron to form OH. Then OH plus OH will give you H2O plus O. Then O plus O will give you O2. O, we can write it in the full and say that 4 OH minus 4 electrons will give you 2 H2O plus oxygen. So in this case, the products of electrolysis will be hydrogen and oxygen. 2, concentration. When chloride ions, bromide ions, iodide ions are concentrated, then they will be discharged in preference to OH ions. Therefore, electrolysis of concentrated sodium chloride solution, when sodium chloride is concentrated, in this case, instead of liberating oxygen from OH, because OH is lower than chlorine in the reactivity series, when chloride ions are concentrated, they will be liberated in preference. So chlorine will lose electron to form chlorine gas. But the law doesn't apply to sodium and hydrogen. Hydrogen being lower than sodium will be liberated at the cathode. So hydrogen plus 2 electrons, you will get hydrogen gas. Based on the concentration, electrolysis of concentrated sodium chloride will liberate chlorine because chloride ions are concentrated at the anode and the hydrogen at the cathode. 3. Nature of electrode. When a mercury cathode is used, sodium ions will be selectively discharged in preference to hydrogen ions. Therefore, electrolysis of concentrated sodium chloride solution using mercury cathode, at the cathode sodium will come out, leaving hydrogen. At the anode, because of the concentration, chloride ion will come out to form chlorine, leaving hydroxide ions in the solution. In electrolysis involving chloride ions, the anode is usually carbon because carbon does not react with chlorine. Application of electrolysis. We can use electrolysis in the production of chlorine, hydrogen, and oxygen. Chlorine, of recent, in Uganda, it is being used in swimming pools. The swimming pools are becoming many, so it can be just your job to produce chlorine for those swimming pools by electrolysis. Hydrogen is used as a fuel. Oxygen is used in the hospitals, is used in welding. So this can be just your career to make these gases by electrolysis. Then 2, extraction of metals. All the metals above carbon in the reactivity series. Remember, I put carbon between magnesium and zinc. So calcium, sodium, aluminium, and magnesium are produced by electrolysis. Example, extraction of sodium chloride by electrolysis of molten sodium chloride. So sodium chloride would dissociate into sodium ions and chloride ions. Sodium ions migrate to the cathode, chlorine ions migrate to the anode. At the cathode, sodium ions receive electrons to form sodium. At the anode, chloride ions receive electrons to form chlorine gas. So sodium is produced with chlorine in the extraction of sodium from sodium chloride. So the initial challenges: first, sodium chloride has very high melting point, 800 degrees. This means too much fuel is used. Using too much fuel means the cost of sodium goes up. The sodium chloride has a very high vapor pressure at 800 degrees Celsius. The vapors coming off sodium chloride is high. So what happens is that when that vapor falls on your skin, sodium chloride absorbs water by osmosis from your skin, leading to death of the cells and then what we call ulcers or wounds. Then sodium at 800 degrees is solved in sodium chloride. All of these were solved by addition of calcium chloride that lowered the melting point from 800 degrees to 600 degrees. Then fourthly, sodium reacts with air. This was solved by collecting sodium in dry nitrogen gas. Then the setup is as follows. You have a cylindrical cathode, which is iron. Iron was chosen because it is cheap and it has a high melting point. melting point higher than that one of sodium chloride. We don't want a cathode which is going to dissolve in the solution. Then you have a carbon anode. We say the carbon is used because the carbon does not react with chlorine. Then sodium is collected in a dry nitrogen. Application number 3, the production of sodium hydroxide. This is produced by electrolysis of sublime or concentrated sodium chloride solution. Sodium chloride will ionize to form sodium ions and chloride ions. Water will ionize to form hydrogen ions and OH ions. So sodium plus and the hydrogen plus will migrate to the cathode, which is the mercury cathode. At mercury cathode, sodium selectively liberated. Then chloride ions and OH ion go to carbon anode. Carbon is selectively chosen because it doesn't react with chlorine. Then chlorine, because it is concentrated, will be selectively discharged to form chlorine gas. The setup is as follows. We know that mercury is a liquid, so mercury flows at the bottom of the container and is connected to the negative terminal of the cell. Then brine flows in. Then we have carbon anode. Then chlorine will jump out from there. Then sodium, after being discharged at the cathode, dissolves in the mercury to form a solution. Sodium mercury solution is added to water. Sodium reacts with water to form sodium hydroxide and hydrogen. So hydrogen is also a product of electrolysis. Then sodium hydroxide solution is concentrated to form pellets by evaporation. The disadvantage of the procedure, it liberates poisonous mercury to the environment.
The Science Foundation College in Namave ku Lwejjinja ng'oyingira kilomita emu. Somero lya Dene Boarding ery'abawala n'abalenzi. Ku O-level tusomesa arts ne sciences ate A-level tusomesa sciences zokka. Omwana mulete ku The Science Foundation College. Ffe tusinga okusomesa sciences. Okumanya ebisingawo kuba ku 0753 8 27 09. The Science Foundation College, based on sciences and based for sciences.
4. Purification of copper. When we are purifying copper, the anode is in pure copper. The anode is oxidized to copper 2 ions and it decreases in size. The cathode is made of pure copper strip. So copper ion is received electron to form copper and the copper is deposited on the cathode. So the cathode increases in size. So electrolyte is copper 2 sulfate solution. Purification of copper has got a historical fact in Uganda because it led to building of Narubale hydroelectricity dam. We received our hydroelectricity dam at Jinja to produce electricity for purification of copper from Kirembe mine. Then number 5, coating of metal with another metal. The metal used for coating is made the anode. The metal to which the other metal is to be coated is made the cathode. So the anode will oxidize to form metal ions which are deposited on the cathode. Laws of electrolysis. 1. The quantity of an element liberated on an electrode is proportional to the quantity of electricity used. The quantity of electricity, Q in column C, capital C, is given by Q is equal to IT. I is the current in ampere, T is time in seconds. 1 mole of electricity is equal to 1 Faraday, is the same as 96500 coulombs. 2. The moles of electricity required to liberate 1 mole of iron is directly proportional to the charge on the iron. For example, sodium plus chloride ion, iodine ions, bromine ion, each requires 1 mole of electricity to liberate 1 mole of its ions. Calcium, copper, magnesium, it requires 2 Faradays because each one has got 2 positive charges. Then aluminium will require 3 Faradays to liberate 1 mole of ions because the charge on aluminium ion is 3. Example 1. Calculate the mass of copper liberated by 1 ampere in 1 hour. First we calculate the quantity of electricity which is equal to IT, and this will be equal to I, which is 1 times T, but we say that T is in seconds, so it will be 1 hour times 60 minutes times 60 seconds, which will be equal to 360 coulomb. But copper 2 plus 2 electrons, you get copper. It implies that 2 times 960, 2 moles of electrons, which is 2 times 965 coulombs, liberate copper is 64 grams. What about 360? Will liberate coulombs, will liberate 64 times 360 over 2 times 96500, which is equal to 0.12 grams. Example 2. Calculate the volume of hydrogen liberated from dilute sulfuric acid at 20 degrees and 0.5 atmospheres by 2 amps for 2 hours. First we calculate the quantity of electricity, which is equal to IT, which is equal to 2 times 2 times 60 times 60, which is equal to 2 times 60 times 60, which is equal to 1447 coulombs. Then hydrogen 2 plus 2 electrons will give you hydrogen gas. Then moles of hydrogen liberated. Then we say that since 2 electrons are required to remove 2 moles of, since 2 moles of electrons are required to liberate 1 mole of hydrogen, then we can say that 2 times 96500 coulomb liberate 22400 centimeters cubed. 1 mole of hydrogen is equal to 22400 centimeter cubed at STP. Therefore, 14470 will liberate 22400 times 14470 over 2 times 96500 times which is equal to 1671 centimeters cubed at STP. Then we change the volume to this condition. We use PV over T is equal to a constant. So at STP, the pressure is 1 atmosphere times the volume, which is 1671, over temperature. At STP, the temperature is 273. Then this will be equal to the pressure at the new condition, 0.5, times the volume we are looking for, over the temperature, which is 273 plus 20 to change it to Kelvin. Which is equal to 3597 centimeters cubed. So after getting the volume at STP, then you change it to volume at a given condition is using ideal gas equation. PV over T is equal to a constant.
Somero lyange bagira ze n'emikwano gyange beera nyumirwa ng'akulenya ensamba beera nyumirwa ng'akulenya ensamba beera nyumirwa lino ggwanga lyange ono zabu waffe olw'ebirungi byereeta waliyo ebinyuma laba ebiwalanfa emisono buli kimu kibeereyo ng'akulenya ensamba beera nyumirwa tugweyo tuwagire timu yaffe tugweyo tuwagire eggwanga lyaffe asobola azanya anyumisa muze yateeba agwira Dr Bbosa agwira muze yateeba